Hello everyone, so I welcome you in this lecture, and today we are going to talk about string matching. String matching is an important task in many of the applications where we are interested to find a pattern or a substring in the given string. You will realize that many of the search engines or searching techniques are also using the fundamentals of string matching. So in this lecture we are going to talk about the basic fundamentals or the foundations of string matching, and we will also discuss some algorithm that will help us to understand that how these algorithms are being devised and developed. So the very first thing is we need to understand some the very fundamentals of string matching, some terminology that we use while we talk about the string matching. So let's start. So string matching basically means detecting the occurrence of a particular substring, we call it as a pattern, in the another string. So in general, the pattern is much smaller than the given text, and we are interested to find out that the given substring or the pattern exists in the text or not. So we are actually searching this substring into the given text. So we are, for example, we are having a text, let's say university, and the pattern that we are interested to search is, let's say, SITY, or you can say this is maybe one other pattern. Maybe we want to find out univ, or if I want to find out uh, city. Now if I want to find out this particular substring, or you can say this string in the given text, then this you will find out because it exists here. Similarly, if I want to find out this pattern in this given string, this is also existing here, we can find out. But when you talk about the city, then when you search in this given text, then this will not be find out. So our interest is to find out any given substring or a pattern in the given text. So let us look to the formal definition of a string matching problem. So here we are given one text of size n, and the pattern we are having of size m, such that m must be less than equals to n. Now to perform this task, to find a pattern in the given text, we have many possible algorithms are already existing here. So the approaches are, one approach is the straightforward solution, that is actually a brute force approach. The brute force approach, we know that it's a very fundamental approach where we check with all the possible options we have, and normally this will give you the solution, but these algorithms are very costly. Then we have some better algorithm known as Nuth Morris Pratt, Boyes Murray, and also we have many more algorithms for doing the string matching. These are the fundamental these are the fundamental algorithms, and in this lecture we are going to talk about these algorithms. Let us talk about some terms that we refer when we talk about the string matching. The very fundamental term is alphabets. So alphabet is a set of symbols or a characters by using which your patterns and text are derived. So what does it mean? It means we are provided a set of symbols, and your text and patterns can only be consisting of that alphabet. For example, when we talk about any sentence or any word in a English like language, then our alphabet set is A to Z. So whatever you say in English, whatever you write in English sentence or a word, it will always consisting of A to Z. So here also, whenever we talk about the string matching, we must be aware about what is the alphabet set. So your text and pattern will be derived from this set, and we are representing it as a sigma sign. Then string is a collection of these characters from the alphabet set to form a word or a sentence. Then sigma star denotes the set of all finite length string formed by using characters from the alphabet. So this denotes all the possible combination of finite length that can be derived from this set sigma. So what does it mean? If I say my sigma is A, B, and C, then all possible all possible uh, combination that you can derive out of this is a element of sigma star. So you can say one is A, one may be AB, one may be A, You are allowed to repeat any number of times these symbols which are defined in set sigma. You may say A, B, C, C, B, A, and so on. So because all these elements are of finite length and consisting of the element defined in this alphabet set, then this is are all valid and this represent the sigma star. The zero length empty string denoted by epsilon is also a member of sigma star. So one important thing, that apart from all these possible combination, we are also including one element that is called epsilon, which is a string of size 0, or we call it an empty string. This is also a part of sigma star. The length of the string x is denoted by bar x. So whenever any string is given to you and we want to talk about the length of the string, then we write the bars in the left and right. So what does that mean? It means if my string is, let's say, city, then if I want to, this is my string x city. If I want to know the size of this string, or when I say size means number of characters, then I will write this like this, and you will get the answer 4. That means we have 4 characters or 4 symbols in this string. The concatenation of the two string x and y denoted by xy has length x plus y and consists of characters in x followed by characters in y. So when we talk about concatenation, concatenation means the combining of the two strings in the order. So if I say xy and yx, their size are equal but the meaning are different. So when I say is xy size equals to yx, then this is true, but when I say xy is equals to yx, then this is not true. So let us say if x equals to abc and y equals to efg, then this is 3, then this is 3. So you can see there that x plus y or y plus x is actually 6 in terms of size. But if I say x, y, this will be a, b, c, e, f, g. But if I say y, x, this will be e, f, g, a, b, c, which is not same. So these are some very fundamental properties that you have to keep in mind when we talk about the string and string matching. So let us take some example. Already we have discussed. So let us look here at how it is working. So this is our sigma set. These are the characters which are allowed to form your string. So one string is x a125. So all the characters are actually taken from this set. The length of this is this. Y is also he69d. It is also, now if I say he69d, so actually if you look carefully, this is not a valid string, because here this string is formed by using one character which is not a part of this sigma. So this is intentionally I have written here this to make you understand that this is not a valid string, because whenever you make a string, it should all the symbols must be taken from this alphabet set. Now 9 is not existing here. Okay, so actually to make this string valid, we are assuming that 9 is also a part of the set. Now this is okay. So h is existing here, e is there, 6 is there, 9 is there, and d is also there. So this is size is 5, and when you do the concatenation, where you are doing means xy, then x will appear first and then y will appear, and the size of this will be 5 plus 4, 9. So if I make any string, let's say p a b k, then this is not a valid string because k is not a part of this set. The other important thing about the string matching is shift. This is very important. Now what is shift? Let us read this line. If P occurs with shift S in T, then we call S a valid shift. If P does not occur, so if P is occurring, P is a pattern and T is a text. So if P is is actually a match with the T, we call it as a valid shift. And if P, that is, there is no match with the T, then we call it as an invalid shift. Now what does that mean? It means this is a text given to us. Let's say this is the text in which we are interested to find some pattern, and pattern is ABAA. So initially when we start working on this process to find a match, we have started from here, let's say from the very first element. So we have to align our text and pattern side to side. For example, this is ABAA. Okay, and we have to match with each individual symbols. Now here you can see that this is not a match. So whenever this entire pattern is not matching with the text, we say this is a invalid shift. So when there's a mismatch, you have to shift it. So now the next part is ABAA. Again you will find that it is not a match. You will say that this is a invalid shift. Similarly, you can keep on shifting it, and when you shift 3 times, so at s equals to 0 is an invalid shift, 1 it is an invalid shift, 2 it is an invalid shift, but when you make a third shift, when s equals to 3, you find that all the characters are matching, and you will say that now the shift is valid for value 3. So here in the algorithm we are using one variable, we are referring it as S, that denotes a shift. So our objective is to find out that for which value of shift we are finding a match, and if the match is not found, we will get some information from the algorithm. So normally we get -1, that match is not found. Okay, then we have something called prefix. So prefix and suffix is something important that relates with the string. Now prefix, as a name said, pre means prior, before, and suffix means uh, post, later, right? So string w is a prefix of a string x if x equals to wy. So if x is a string given to you, and if we are able to write x equals to wy, means if we are able to represent using two partition, then the first partition you can say is a prefix. So, and keep in mind that w and y must be a part of summation star, sigma star, right? And we are representing this as w left bar, or you can say the left bracket x. That this means that w is a prefix of x. So let us take one example here. Sigma here is AB. That means you can drive your strings consisting of these two symbols A and B. This is one string given to us, and if you write AABBAA, then this will be W. Now the primary condition of W is it must start from the beginning, and also it must be a part of the string. What does that mean? This is one example of W. W can be also AAB. This is also valid W. It can be AA. It can be A. It can be AABBA. So these are all the example of W. But we cannot say that W is A B B A. Though this is a valid pattern which is existing here, but it does not start from the very first character, so this is not a W. So whenever we say a prefix, prefix must always start from the very first symbol and must match with the given text. So let us see here. This is our set. This is your some examples of sigma star where all the elements are derived from this AB. This is your X, and now we have to find out is W is a prefix of X or not. So this is only possible when it starts, it will match from the very first character it is matching, but along with this all the characters must match. So it is, you can, this is a match, but this is not a match, and that's why this is not a prefix. So the two primary conditions for prefix is that the first character of the text must match with the given prefix, and all the characters, corresponding characters, must also match with the corresponding characters in the given strings. Then only it is said to be a prefix. So here only the first condition is match. It's actually true that the very first character is matching, but all of the characters are not matching. So this is not a prefix. Then we have suffix. Suffix is just opposite to the prefix. Here we are looking for a string which is the last part of the given text. So here in the prefix we have write it as wy, where w is we are calling as a prefix, a part of the string which appears at the beginning. Okay, and if I write yw, here our this part of or this substring is actually occurring at the last. So this becomes the suffix here, and we need to keep in mind that w and y must always be a part of sigma star. Sigma star refers that all all the words are derived from sigma set, and for suffix we are using this right bracket x. So w is a suffix of x and w is a prefix of x. These are the notation which are being used. Now let us look to some example here. So here sigma is AB, we have provided the string, and then we have something W, and we have to check that W is really now this is for prefix, right? So is W is a prefix of X? So for the prefix we need to check that does it start from the very beginning? Does it match from the very beginning character? No, it does not match with the very beginning character, so it is not a prefix. Is W is a suffix of X? So you need to check that does it match with the last character. The last character of the W is matching with the last character of text. Yes, it is matching. Along with this, the entire symbol, the entire pattern, the entire W characters must match with the corresponding characters given in the text. So let us say our this is B A B A B, and if you find this is matching, matching, match, match, match. So W is actually a suffix of X but not a prefix of X. Okay. Does a W can be a suffix and prefix for any text? Is it possible? Yes, it is possible. So let's say if this is your string A B B A, and if I say W is A, then in this case you may realize that the W is actually acting as a prefix also and also the suffix also in this case. So it all depends that what is the nature of your given string. Okay, so let us talk about some algorithms that can provide the string matching. So we'll start with the very first algorithm, that is called naive string matching algorithm, and this is a brute force based algorithm. So here we are not using any heuristics, but a very simple approach where we are doing where we are just searching for searching with every possible character by character to find that pattern is matching with the given text or not. So it takes the pattern that is given searched for in the base string. So we have provided with the pattern that we are looking to search in the base string. Base string is a main text in which we want to find our pattern. So in our notations we are calling this a base string as T and pattern as P. Slide it across the base string looking for a search. So in general this is the kind of scenario. We are having this text given to us, and then we have a pattern. We keep the pattern just align with the text, and we keep on checking that every symbol of the pattern is matching with the text or not. If it is not matching, then we keep on sliding. For example, if this is not a match, then we will just slide it again to the next character and the next character and so on. So this is a kind of exhaustive search where we are doing a match with the every possible combination of the text and the pattern. it keeps track how many times the pattern has been shifted in variable s. So whenever we are shifting, we keep a note of this shifting, and we are using one variable s, you can say, which will keep a track that on which shift the match is found. And if the match is found, we call it as a valid shift. Already we have discussed. And when the match is not found, we call it as an invalid shift. So our objective is to find out that how many valid shift has been identified in this process. When a match is found, uh, we print the statement that pattern occurs with shift s. So if we are only looking for one pattern, you can stop at that point whenever you find a valid shift. Otherwise, if you are looking for all the patterns that is existing in the text, then you keep on shifting until the algorithm says to you. And this is a brute force algorithm. So we will be discussing some more basic points about this, and then we will take one example and we will apply this algorithm to see that how it works. Okay, so look here, we have example here as well, also the algorithm. So let us look to the algorithm first before move to the examples. So this is the name of the algorithm. We are calling it as a string naive string matcher, and it takes two input. One is the text, the main string on which we are interested to find the pattern, and the pattern, the substring that we are looking for in this text. The length of the text is n, and the length of the p is m, and in general m is actually very less than n, but the condition must satisfy is m must be less than equals to n. For s equals to 0 to n minus m, we will doing one loop here. We have to perform some task this number of time, n minus m times. Now why n minus m times? Because after this the pattern will go beyond the text. What does it mean? It means if it is a b c d d e f and you are searching for a b d, for example, right? So that means uh, once you reach here, for example, this is not matching, then you will reach here a b d here, then you will be matching here a b d, and then you will be matching a b d, then you matching a b d. Now what you will observe here, when you reach to this situation, then if you move, if you make a shift here, then you will go like this a b d, and your pattern is actually beyond the range of the text. That means you have to make up to this much shift, and this much location is actually you are doing from this size. If the size is n and this size is m, so you have to do a move of n minus m, because after this every shift will be taking your pattern beyond the limit of the text. So that's why we have to do this matching up to n minus m size. So if p 1 to m equals to t s plus 1 to s plus m, so with that means we have to match every character of pattern with the every character of text. If it is matching, then only we will say that pattern occurred with shift s. So you can see here that this is something given to us here. This is pattern, and so if you see here, this is s initially is 0. So when you match with 0 plus 1 means this match with this, okay, but this is also matching with this, but this is not matching with this. So what it will do, it will shift a next position, okay, means it will shift to one character, and then you will keep matching again. So likewise you keep on doing until you find a match, or you will uh, go beyond the limit, which is actually you have to do up to n minus 1 n minus m. So the input is p and t, we need to pass the length of the text, and the pattern must to be defined, and pattern must not be non-empty, because pattern must have some size that we are looking for. And what we expect uh, the index of t where a copy of p begins. So if you find a valid shift, we want to find that index, at which index we find a match, and if there is no match is found, then it will return -1. So let us look to this example. This is your text given to us. This is the pattern. So what we will do, we will simply just match character by character. So here you can see this is all matching, but this is not matching. So what will happen, because keeping in mind this condition, every individual symbol must match, otherwise it will uh, give you a false result. So this is not matching, that means it is not a valid shift. So you are going to shift this to one position. So it will shift it to one position. Again you will do all the matching, and here itself you will find that this is not matching, this is invalid shift. Again you will shift it to one position, and you will find that this is now a valid shift, and you have find your search. So you can say that s equals to 0 1 2. So at the second shift you have find your valid shift, and a pattern is found in the text. Let us talk about the time analysis. It's always required to find the time complexity of the algorithm, so that we are in a position to analyze it. We are able to compare with the other algorithms. So this is the algorithm. Already we have discussed that how it works, and now we will do analysis. So n here is the length of the string being searched. This is the t, the text size, and m is the size of the pattern. And again repeating that m must be less than equals to n. And in general, actually m is very less than compared to n. N is a very a text of larger size, and m is a text of smaller size. But this is the monetary condition. So every time what is happening, we are comparing each characters of m with the each character of t. So if m is having a b c, let's say this is the pattern that we are searching. So you are searching three characters with the characters of, for example, this is x1 x2 x3 and x4 and so on. So every time you are doing three comparisons, means you are doing m comparisons. Okay, this is the size of the pattern. So you are doing m comparisons, and how many times we are doing this comparison? We are doing this comparison to n minus 1 times. N minus 1 time is the actually the last character, which is a last limit, where this m will be inside the boundary of the text, and when you uh, do the next time, then it will be n minus m plus 1. So if you remember, when you are making a loop for I is equals to 1 to n, then up to n condition it is true, but you have to check for n plus 1th time when it will become false. So we are always doing plus 1 time for loop. So here we are having a loop n minus 1. So we are doing n minus 1 plus 1 comparisons to check the status here, right? So the effective running time will be, you are doing m comparisons in each iterations, and we are doing n minus 1 plus 1 times this job. So the running time will be m into n minus m plus 1, or this you can also write as big O of n minus m into m. So this is the effective running time comes out in this algorithm. Let us look to some observation. The naive string matcher is not an optimal solution. This is not the best solution, though we are getting the answer, because it's an exhaustive approach. This is a brute force approach. So definitely with the brute force approach, one thing is guaranteed: if the solution exists, you will get the solution. But this is not an optimal solution. Brute force solutions are normally very costly solutions. It is inefficient because information gained about the text for one value of s is entirely ignored in considering other values of s. Now this is the major drawback of this approach, and because of this algorithm is said to be very costly. Now what it says, whenever we are doing a matching of every character in the pattern with the text, and after doing all our effort of matching, if there is a unmatched character found, then we take it as an invalid shift, and then we move our pattern one position and start the process again. Now this will something which is actually make this algorithm costly. What does that mean? Let us look to one example. So let us understand that why this algorithm is not good, and why it is costly. Suppose the P pattern is this and the text is this, and this is the text, and we are looking for a string matching. So we will write our text here. This is A B C. Okay, so at the very first match we will find that this is not a valid match, this is not a valid shift, so we will going to make one position shifting here, and then you will find that it is actually matching, but this is again not matching. So as a whole this is not a valid shift. So again you will shift one position, and again you will find that this is not matched, the very first character itself is not matched. So you'll make a shift, and then you will find now it is matching. So what is the observation here? The observation here is that if you look to this scenario, we find this match, and this is unmatched. The moment you find unmatched, you start the process again with the next character, means you will start again comparing from this position. Now here this pattern is of only 5 size, but in the real life when we use this kind of algorithm, our text may be of the 1000 size, and the pattern may be of 250 size or even 1000 size, right? We are looking for any text which is of this much size, and let us assume that when you are comparing each character and you find that almost 500 or 600 characters have been matched, and then you find a mismatched character. So all the effort, means all this matching is is actually gone waste, because in the next iteration you have to again compare with every characters. Now this all effort is actually got wasted, means there is no information about this matched character. So we are looking for some a smart algorithm that can take into consideration that if some characters are find matched with the text, then do we get some useful information with this kind of scenario? Can we skip some some more position to avoid the matching again and again? Because in this method, what is happening, once there is a mismatch, you simply go back and again do the same process with just moving to the one position. So there may be a repeated task is actually happening, because all the effort that we have did in the previous effort of finding the match character is of no use. So we have some algorithm that we are going to discuss in our next lecture, that how this information, if something is find matched, then how we can get this information to skip some more position and avoid that our number of comparisons, and as a overall effect we can reduce the overall number of comparisons, and that will also reduce the running time. So this is all for this naive algorithm, and in the next video we are going to talk about the KMP algorithm, uh, a better approach of string matching. So this is all for this lecture. Thank you very much.